better than two.
Welcome, everybody, back to another episode of Sweet Home Catoosa. Hope everybody had a fabulous Christmas. We're recording here on the 30th, but you'll see this in the new year, so Happy New Year's to everybody. Today, I wanted to reach out, and I was lucky enough for these two gentlemen with their credentials, as they'll tell you in a minute, to come and talk to us, because something came online here a little while back on Facebook. Our great Mayor Millwood down in Ringgold, put that they were going to transition from one water source to the other, and he just kind of casually said, what does everybody think about fluoride continuing to be in the water? And I'm just like, wow, I've never really thought about it. And it got me thinking, like a lot of folks, and there was a lot of comments for folks that were for and for against it. But with that and what's going on in Whitfield County right now with what they call the forever chemical, and I know folks have seen Aaron Brockovich down there. They're all lawyering up and everybody's pointing fingers, but we'll talk about that as well. But so we've got a lot of important things right now. I just figure we start the new year off with a pretty important topic to kind of educate myself along with everybody else, come along for the ride to learn more about these things. So these two gentlemen came, and so we've got James Burgess and Eric Crisp, and thank you, gentlemen, for coming and being a part of the episode here. So we're just going to jump right in. So, James, kind of give us your background. And
all right, so I'm Dr. James Burgess. I grew up in Lafayette, Georgia, went to West Georgia. Then when I went to Alabama for graduate school, do not hold that against me. And then moved around. I lived in Ringgold for about 7 years, and I actually got to know a lot of the people on the council at the time, and so I've got roots here and in the area. So my background's analytical chemistry, which is, kind of the study of things like fluoride content and things like that. Like, we find out how much is in water. So that's kind of my background in all this is, I know a good bit about water quality. So we both actually have a research project together on microplastics in caves. And I talk about water quality a good bit.
thank you. Eric?
Well, so I grew up in Trine, then left and literally went around the world in the Navy. Ended up with a first degree geology, and so I'm a geologist and I'm a chemist. Second undergrad degree was chemistry. You did your grad work all at Tuscaloosa, and I did UAB Birmingham for chemistry and Athens for geology. So, so we've kind of got it mixed up a little bit here. So geology and chemistry, spent a lot of time doing groundwater stuff in the geology world. A lot of pollution remediation, a lot of investigation, stuff like that. So groundwater and water in general is kind of my world. My favorite flavors of chemistry include the analytical, like James does, but also did a lot with chem ed, how we try to teach this thing that we call science.
Well, that's it. So today, I know there's probably going to be a few things I'll probably have to say, wait, time out, and I dumb it down for me, right? You two gentlemen are brilliant at it, and I'm just trying to catch up. So I'm sure. So did you guys see that post? I think, you might have seen it.
Yeah,
so
I saw
it half the folks, it seemed like, and we're talking hundreds of comments, seems like it was about a 50-50 spread, and I didn't take the exact poll, but a lot of folks were like, stop it, and a lot of folks were like, hey, there's a reason it's in there. So I'm going to let you two guys educate me on how, why is it in there, and why should we keep it or not keep it?
So when I first saw the invite from Elliot and started talking about this, my knee-jerk reaction, I think, was that I was 100% for continued fluoridation. And then I thought, well, I need to do due diligence and let's do a little bit of research. And I think now where I've ended up, I'm about 85-15 still for. It's less than 100% my knee-jerk reaction,
right?
But I'm still very, very pro continued fluoridation. James, where are you?
I'm still, I'm never 100% anything.
Fair enough.
I'm still pretty, I would say 95%. And when we give percentages, we're being actually exact percentage.
Sure.
I don't think we have to be exact for this. Very,
yeah.
very.
So
Okay.
very still pro. Eric had sent me a water quality or fluoridation and IQ related
Sure. That was
paper that we'll talk about. Honestly, it has been shown time and time again to reduce cavities. They've done all sorts of health studies and everything like that. And the recent studies that have come out are coming out of places like China, and it's super high levels. And then China also has a lot more lead and arsenic and things like that in the water. So I'm like, yeah, when you're getting into countries that don't have the level of water quality control that we have,
Right.
It might not just be fluoride that's causing the lower IQs. But yeah, I'm still pro fluoride.
So the first thing I looked at is just what is fluoride, right? And so the definition, right? Fluoride is a naturally occurring mineral found in rocks, soil, water, and certain foods. It's the ionization form of the element fluorine. So sources naturally found in groundwater and seawater. Synthetic fluoride, which, here again, educated, right? 2 types, is commonly added to municipal water supplies. So,
Yeah, so one of the things I do think we need to talk about is the idea, and I want to ask this in a more general sense, but synthetic fluoride. Now, not to get too deep in the weeds, right? But fluorine is an element, okay? The only way that you're going to synthesize an element is with nuclear reactions. It's not like the other thing that you said we might talk some about with the
Right.
Field County stuff. The fluorinated compounds, now that's a different thing. You can synthesize those with chemical reactions. But fluorine itself is an element just like chlorine or oxygen.
We have all the fluoride we will ever have already before and after, like before we change it from one form to the other. Because that's really, we're not making fluoride, we're changing its form. And like the fluoride, that's the F-, the ions, that
Just about the
they don't
electrons.
use that anymore in fluoridation most places. It's actually, that's called free fluoride, so it's not bound to anything. So what we use, and that's where the synthetic comes in, is something with basically same structure as sand with fluorine groups on it. We get it through a synthesis process as a byproduct, but it's also naturally occurring in some minerals.
And that's why I brought this. That I collected I'm pretty sure this was on the Illinois side of the river, but it's right in the southern Illinois, western Kentucky region, Cave-in Rock, Illinois area. And this is naturally occurring fluoride. So it's calcium. So calcium with 2 fluoride directly bonded to it in the crystal structure. And ran the calculations, and if you use this little bit of fluoride crystal right here to fluoridate water to our typical concentrations, that much would treat 20,000 gallons.
wow.
So it's not very much that we're talking about.
Right.
And that's just not the whole rock, it's the little crystals in the rock, which
Yeah,
you're
in the rock.
not going to pick up. Yeah, it's just the little crystals in it. So fluoride can be naturally
And-
available in some regions.
And what I was thinking
Yeah.
with your studies that you were looking at, those Chinese studies, we were looking at some of where they're coming from on that. If you check the fluoride levels in that portion of Illinois down there in the southern tip or western Kentucky, you're going to see a lot higher fluoride levels in the water there than you would here because it's naturally occurring in the ground, in the mineral
It's not being
suite there.
controlled.
And I think that didn't you see a lot of the studies in the Chinese? You did some stats on that, and they have, like that rock, they have a lot of naturally occurring fluoride at a lot higher levels than our 0.8 ppm.
Right, what's added fluoride. I don't know if it was just misadded, the high levels, but
We don't know
it's
what
a
their
lot.
source
It's like
fair.
4 to 5 times what's allowed.
So
Yeah.
So we probably need to talk about concentration a little bit and things.
Sure,
about-
because that's what a lot of folks, right? They're
Yeah.
saying the people that say no are saying, hey, there's things, and they get on Dr. Google, and they get on there and say, oh, hey, I mean, it could cause health problems, and that's where that's coming
So
in.
one way to look at concentration, Atlanta's about 1 million people, right? Is Atlanta 1 million people?
I think it's more than that, but go ahead with it.
Okay, let's say Atlanta is 1 million people. All right, so the amount of fluoride that would be in water would be what?
Less than.
70% of one person.
Yeah, less than one person.
Yeah, so it would
like a
be
little store.
less than a person sitting around in Atlanta.
Yeah.
So that's how low of a concentration we're talking about.
Yeah. And I wanted to delve into the concentration idea a little bit too, because a lot of the stuff that I'm seeing, I've been trying to figure out, and I'm open to if you have a good answer for this, of what are the reasons folks are resistant to the idea of fluoride. And one of the things I'm worried about with it is that we're not looking at concentration effects. An example that I wanted to use for concentration is oxygen, O2. So we think of oxygen as a good thing, right? Because if you're breathing air that doesn't have oxygen, well, you're not breathing it for long.
Right.
So, but concentration matters. So if you're breathing air with 21% oxygen, fine, everything's great. But if you start breathing air that's 30% oxygen, it's not great. Things are going downhill in a hurry. So that concentration matters. So if we're looking at 0.8 ppm, which I think we saw 0.6 to 0.8 for Ringgold, is that right?
Yeah, that's
Off the top
the
of my head,
national, that's a U.S. national.
That's a different thing than these Chinese studies that we're looking at, 3-ish, 3 to 6, you said?
Yeah,
Parts per million?
yeah.
So that's a lot different than like we're talking about with the oxygen concentrations.
Parts per million is like I was saying about Atlanta. So that one person would be 1 parts per million.
Yeah, it kind of waters it down. So somebody on here said the danger, so it's fluorosis is what they were saying. It's the danger of fluoride in water is that it can cause fluorosis, an increased risk of osteosarcoma and impaired brain development in infants and children. So that's where hey, wait, this could cause problems. But here again, that's when you get into the overconcentrated
Right.
part.
And fluorosis itself is a broad term. So you get some of the studies that say you get a risk of fluorosis are only talking about the cosmetic damage, the brown spots.
Yeah.
Right? That's where you're looking at. I believe that was 6 to 8 ppms. When you're getting the skeletal deformities and stuff like that, you're talking about 19-20 ppm, a lot higher than what we're talking about.
20 times higher.
Yeah. So another person said, I grew up drinking well water, which means he had no fluoride, and have had only 2 cavities in my 50 years of having teeth. Research has shown that fluoride can lower the IQ in humans. My grandpa lived to 89 drinking well water and kept his intelligence and memory, yet his city-living cousins died of Alzheimer's at age 70. So here again, it's such a broad spectrum because, listen, I'm reading those, but there's so many more that are like, hey, there's a reason it's in there and we want the benefits. But these are some of the things that people are worried about, right? And,
You actually ran some of the stats.
Yeah. So there was it National Institute of Health?
Yeah.
Did a report on like the literature on IQ and fluoridosis or the fluorine levels.
Review articles.
It is a reviewed article, so it was looking at other studies that other people did. So when they did a search, they found 72 studies talking about the link between IQ and fluorine. 53 of those, which turns out to be about 75%, they threw out because they weren't any good. That would have left them with about 19, and then I went through the 19. And when you really look at for one thing, the average of the high water was about 3 parts per million. So it's about 3 times higher than what's allowed. And the IQ drop was, let's say the high IQ could be off plus or minus by 12%. So
12 points out of 100.
How much they're off, if it was 102, that means it could be 12 less than 102 or 12 higher, and every IQ high or low had that same error. So if you look at how much error there was, you really can't tell the difference between the IQ studies. And, you know, like I said, it's 76% they had to trash. There were the only one that had low fluorine or had the lowest fluorides and the best data. Actually, there's 3 papers from Canada, and 2 out of 3 of them showed there's no significant change. The other studies out of the 19, 10 were in China, 3 were in Mexico, and 3 were in India. And that's where that whole problem of, well, these are countries that don't have a lot of environmental controls.
Yes.
So, yes, fluoride was in play, but what about lead and arsenic and mercury and all the other pollutants that could be in the water? So that linked IQ is just not really strong.
Yeah.
The studies show, you know, maybe, but that's all at the higher levels. So at reasonable levels, there's not been any studies that show there's any link. The well water thing, you know, did they brush their teeth? Because if you brushed your teeth every day, guess what? You've been putting fluorine into your body every day, and you've been, like, the water fluoride is there as a booster for whatever's in that toothpaste. So if you've been using toothpaste, and, you know, honestly, it's all data is anecdotal on the small scale, but my family, everybody who went well water lost their teeth when they got older. It's pretty common. Maybe that person was lucky. Maybe they brushed twice a day, stayed away from sugar. I don't know.
Yeah, and it's there's so many variables there, right? I mean, growing up, like I said, I went and got my teeth cleaned at the community college, and they did a fluoride treatment every 6 months. I'd pop it in my mouth, hold it there for like 15, 20 minutes, right? You know, so like you said, we get it in so many other ways. Water, being in the water is just an added boost, as you said. It's not the cure-all. It's not like you don't have to brush your teeth because you're drinking fluoride in the water.
You wanted to bring up the correlation and causation with the studies.
Yeah, so like I was saying, they tracked fluoride. Some of the studies looked at heavy metals and things like that in the water. The thing is just because it correlates doesn't mean that's a cause, and that's a common problem that people have with science. And the best way to describe the difference between something correlating mean they both happen at the same time, and one thing causing the other. There's a funny one I like. It's the consumption of ice cream is directly correlated with the number of drowning deaths. Have you ever heard that?
I haven't.
It is directly correlated. It correlates whenever you have increased ice cream consumption, you have increased drownings. Do you know why?
No.
Because you eat ice cream in the summer. You go swimming in the summer.
Right.
So they correlate great. They track. But the cause...
It doesn't mean they cause each other.
No, they're not.
Now,
that's
to
a great
draw that
example.
back, then, that same idea, the correlation, and what a lot of these studies didn't control for. So this sample, right, that I said if you go to southern Illinois there, you'll see a lot higher fluoride in their groundwater supply. You'll also see that what this is famous for is called Mississippi Valley type lead zinc deposits. So you will also see a very high level of lead in their groundwater. And a lot of these, you said 7 did, and the rest did not control for the lead.
Yeah, something like that.
So a lot of these studies just looked at that fluoride IQ correlation and didn't control for other potential causalities, like, oh, by the way, there was also high lead.
Right.
Right.
And it takes a lot less lead, to harm you than it would fluoride.
Good points. Very good points.
And the idea of, if you know what the concerns are, someone who shall remain unnamed, let me know immediately. Oh, their concern about the fluoride is quote, it crystallizes your pineal
Yeah.
gland and doesn't allow you to astrally project. So, okay. That, you know what? We're not in the realm of science. I can't test that. So I can't
Right,
really,
right.
Yeah.
I can't help with that part.
Yeah.
So,
Yeah, I came up on that one. Yes.
okay.
I just saw that. Yeah. Wow.
All right.
Yeah.
Well, okay.
So he's
Wow.
not the only one.
No. Yeah. Like I said, it's just so. I mean, it's so back and forth. But most people. Most people at the end of the day, it's just like this person right here says. I just want to keep the water as clean as possible. I just want the best water source for me and my health and the health of everybody else.
And I think,
well water is the way to go. I'm not
because it's
dissing
going to
well
be
water.
treated. Maybe.
Yeah.
Maybe. But having drilled a lot of wells,
Oh, really?
I'm going to say maybe. It depends on what's on upstream of you. What's up?
Well, sure. Now that
upstream.
brings us into the next thing we could get into in a minute with that, because yes, you don't control what's getting put in upstream, which does affect that. But
Right.
yeah, I mean, the idea is Ringo's not going to open up a well, pull this water to the surface, and immediately send it down the line.
And it's not all H2O.
They're going to treat it.
Yeah.
I mean, so it's not like that. And I think a lot of people in their mind just think, well, you're going to, put a hole in the ground. The water's going to come up. It's going to just shoot in the pipes, come to my house, and I'm going to drink it.
Right.
No, it's not the way that works. And I know they'll get into more of that, but, they've got to either put the fluoride or not, which, that's going to be their decision ultimately. But they treat the water. I mean, it's not just sent right out to you.
And I think
there's a
we see
process.
this as just another treatment.
Yes.
I would prefer that I get my water from Chattooga County, and I would prefer for them to continue to put chlorine in it also. Not because I like the taste of chloramines or whatever it is that by the time it gets to my house, but because I'd rather there be that in there than cholera.
Yes, and bacteria that could
Yeah.
really harm you or cause you problems. Absolutely. Absolutely. So you broached it, so we'll go ahead and go down the hole there. It's what's upstream, what's getting put in there. And so that's where we're down in Whitfield now, where they're having these problems with PFAS, which for most folks like me, common folk, just it's what they call forever chemical, right? And where that's originating from, and this is the broad scope of me, is, we've got a lot of carpet treatment plants, Mohawk in particular, and this one's in the lawsuit, saying that they didn't realize the chemical they bought from 3M during the process had this in it, and when they discharged it, it's now there.
Sure.
It's not forever, but the way it decays, it's pretty close to. It's forever for us. And so now you've got lawsuits flying because they say that it's bad. It does cause issues, and so. I'll let you explain to this chemical situation to us a little bit more to educate us.
So what the PFAS are polyfluorinated alkyl chains. What that means is that it's carbons, and this isn't the same kind of fluorine. So there's fluorine that's an ion. That's what we
This
had
is
been
not an
talking
ion.
about.
Yeah.
This is fluorine that's bound to something,
Covalently bonded.
and it's very, very stable.
Right.
It's a very, very strong bond between a carbon and a fluorine, which means that it's super stable, which is where that forever comes in. The good side of stable is it's heat resistant, it's washable and things like that. The bad news is it doesn't go away.
Yeah.
And it also repels water and oil. So what it's used in is, Teflon is an example of that kind of compound.
Yeah.
So when
Non-stick cookware.
Yeah, nonstick cookware. And if you're making carpet that you want to be stain resistant, it is a very good chemical to put on there.
We always call that Scotch Guard, right? Because that was 3M's brand. That when you treat it with Scotch Guard, you can spill a drink on it and it'll just wipe right up, right?
It will, because the
Nothing
fluorinated
sticks to
aliphatic
it.
are not going to react with it. So
Yeah.
they're not going to stick, right? And there are other things. The military is dealing with this a lot because, like aboard ship, I fought one diesel fire on the ship, and my hat's off to all you firefighters out there, because I fought one diesel fire aboard ship, and that was about 3/4 more diesel fire than I ever needed to fight.
Wow.
I don't want to do that. But you want your AFFF, your phone. you've got to have that. Well, fluorides.
It's in there
Because it
too.
won't burn.
Yeah.
Yeah, and that's the thing. Like the health studies for those, it's really talking long term, and like it's the science is still young on the health effects of it still. So I'm like, I don't know if it's how much fear mongering is involved. It's probably not healthy if it stays in the body.
It does bioaccumulate.
It does bioaccumulate. Yeah, it's probably not good for you, but it's long-term effects.
And if you look at that fluorine sticking off the edge, there's how many drug studies we've done with those fluorines because it's about the same mass as an ethyl group, and it just doesn't break down. So it can do some shenanigans once it gets in the body.
Yeah, because they say cancer studies link the PFAS to kidney and testicular cancer, thyroid disruption, so it can interfere with your thyroid hormone production, immune system suppression, which you never want your immune system to be suppressed, reproductive and developmental issues, so low birth weights and developmental delays in children, and then cholesterol levels, exposure associated with elevated cholesterol levels, right? So that leads to heart problems. So, it's a whole thing. But, so it gets in the water, and then here we go, right? So that's where people think, hey, we're going to get well water. That's great, but the source is. But over time, something could leach down and eventually make its way to a source that's currently not there.
Absolutely. And a lot of the research that James and I do together is in caves, right? And we are literally in the groundwater. Now, we're not looking for PFAS, although you've got an LC, you might could. You need a tandem mass spec, I guess.
I don't have it.
Yeah. But we're a lot of times looking for microplastics, right? Now, you would think in a deep, pristine cave, groundwater aquifer, right, that
it would be uncontaminated, right?
Through when
we haven't been able to contaminate
that we have zero clean samples.
Yeah, they all have some. Yeah,
Every cave that we have looked in, that's your groundwater.
Yeah.
And some of these, it's, we're downstream of where the water's coming in through the ground.
Yeah.
And getting filtered through. So
now those are big. They're not molecular size, right? Those are, depending on what our definition of microplastics is, sub 5 microns or whatever, but they're thousands and thousands of times larger than a PFAS molecule.
Yeah.
Right?
Well, and it's harder. Yeah, it's harder. It would be filtered easier
than the PFAS. The PFAS is going to be there also. Now, I can't say that I've analyzed and can point to that, but it's going to be there also.
So, well site choice, hopefully there will be a lot of thought put into it.
Sure.
You know what we need? We need a local company that would analyze for this. I thought you were going to do it.
A little self-plug, and there's nothing wrong with that. Yeah, we appreciate it. But so you're right. Where you get it and where you drill it and all that is hugely important.
It is.
Yeah.
Because you're not looking at just where that is. You're looking about what is up from that
where's it
currently and what's making its way there. And,
and what's already in it.
North
from the aquifer.
North of town would be the safest bet, I would think, right?
Well,
there's no factories between here and...
But there's all of Chattanooga.
Is that the direction of the groundwater flow? Because you got the ridge.
Especially with karst.
You got Taylor's Ridge.
You got a dye tracer for karst.
I know, but you got Taylor's Ridge.
You can't guarantee that with karst.
Okay. So dye trace? Yeah. So hopefully, I don't know if you know or what kind of...
I don't.
Yeah.
I'm sure the council down there will, and I know them, and you know them.
Yeah.
They're great folks. They're going to do their due diligence,
Yeah.
and they're going to release, everything. And I thought that was great of Mayor Millwood just to say, hey, here, you always want input from folks, and it's something so important. And so we jump back to fluoride for a second. Yeah, my first thought, like a lot of folks, was, well, do we need it or not? Because a lot of people say, Well, heck, I mean, how much water do we consume nowadays, right? You know, most of the water comes right here in a bottle. We buy it or we go somewhere. So we're really not drinking as much water from home as we used to. And then, sure, we're getting toothpaste is giving us our fluoride and all these things. So why is it even necessary? But not everybody buys bottled water.
But and filtered water from the home filter is still going to have the fluoride in it.
Yeah, it's not going to filter out down.
Good to know. So if I have a Brita and I fill it up,
It'll still have fluoride.
you're still going to have fluoride in it.
But
Didn't know that.
if you don't drink water, if you drink something else instead,
Sure.
right? My coffee that I make in the mornings, that's going to be the same water, right? Or if you get, this is a Dr. Pepper.
And you got it where, though? You go ahead and plug them. Here at Ringgold. So, got it from Jefferson's. Yeah, got it from Jefferson's down in Ringgold.
We should have told them before.
Yeah, I know, right? Hey.
But that water.
It came from that water source, right?
So even if you're not drinking water out of the tap, yes, you are.
And
Yes.
Coca-Cola and bottled water and all of those
Where's it coming from?
treated.
Yeah.
Yeah, so.
So there's the argument there, right? I mean, you may not directly, but indirectly you are. Like you
Right.
going to
Yeah.
Jefferson's, you might not drink it at home, but you're drinking it while you're out. And what does most folks get? My wife and I are that way now too. Unfortunately, I've had to give up the sugary soft drinks. That's why you see me putting flavoring in bottled water now. But we drink water at the restaurant. So, yeah, you are getting it, right?
Yeah.
And so it's very important to figure out, is it good or is it not? And I think both you gentlemen have made a good case so far that, hey, I would err on the side of we still need to have it in there.
I mean, there was a couple of, there was a pediatric dentist that made a comment.
I saw that.
I saw
Yeah.
that one. And I feel like that kind of should hold a little water on there.
You would think, well, one of them gave a plug to another dentist in the area, and he said, boy, his business will go way up incrementally if they decide to take it out. But, just so many people.
There were a few people that said no chemicals at all, and we wanted to talk about that.
Yeah. I mean, there is the argument that I made earlier that I would prefer for them to still chlorinate because of the color or other whatever.
Right.
Right. But it's not pure H2O. Right. So you just opened that bottle of water.
Yes.
Right. And so
Drink a bunch of
would you prefer, well, that's true too. I was going to talk about carbonic acid though. I was going to ask you how you would feel about drinking carbonic acid solution.
And he's drinking a base.
Yeah. Okay. It's probably not. That's not.
Okay, so everybody is along for the ride here. I've got from Kirkland's, so Costco, for whatever reason, I decided I like these ionized alkaline water, right? Because, I'm too acidic and I need to, so I thought, hey, the big thing is I've got a nice skinny bottle and I can fill a lot of water. And if I consume this whole bottle instead of a little bottle, then it's better for me as far as how much water consumption I'm getting.
Instead of me wasting 15 minutes of our time, I'm just going to look at that alkaline water, claim y'all heard me be triggered and go off, and then we'll just
That's
all right.
So it's doing me no good, in other words.
I just kind of wanted to go on a quick rundown. We can go together on the chemicals that are put in. So, like the chlorides.
Chlorines usually, aren't they?
Yeah, chlorines. Those compounds are there to kill bacteria like E. coli. And imagine if there's a cattle farm above the well. You kind of want it there, all right? The fluorides for teeth.
Now, they put in some stuff that they're not putting in there specifically to treat, to send to you. They're putting some other things in there that are for the water itself, like flocculants and stuff like that, in order to try to get some other stuff out of there.
Right. And
permanganates especially.
Right, yeah. So there's a lot of things that keep the dangerous minerals out. And another thing around here is big, really important, is the water hardness.
Yep.
Like even now with treated water, where they get it as soft as they can, legally, they put as much as they can to get it as soft as it can. You still get the scum around faucets and things like that. If it was not treated, it would be multiple times worse.
Yeah.
So like all the chemicals they put in have a purpose. They've been tested. They've been, there's
For most of us common folks, this is what, and this gentleman said it exactly right. He says, I don't care either way about fluoride or not fluoride. I wish the water had less calcium deposits as it kills my water heater. So anybody that has a hot water heater knows that all of a sudden through the years, all of a sudden you're like,
last week.
man, I don't seem to be getting as much when I fill the tub, right? What's going on? Well, you go out and figure out that about this much sediment, calcium deposits are in the bottom of your water heater, and that element's buried in that. And so now you're all.
Now, is there more calcium in well water?
Yes, I was going to say. Depending on which aquifer you tap, right? And we can talk about the structure, the different layers underneath this.
Okay.
But if I were just, knee jerk right here, I would probably sink a well in the Knox Formation, and that's going to have very, very high calcium concentrations. It's going to be a very hard water.
Yeah, so
As
just so you
defined
guys
by
know,
guideline.
the rock around us mostly is limestone, and limestone's made out of calcium. So it's like almost
Calcium
pure,
carbonate.
it's calcium carbonate, it's almost pure calcium. That's why we have such hard water.
And the Knox is a lot of dolomites, which are calcium and magnesium carbonates, with a lot of chert.
But smart water, they add calcium. So we've got natural smart water here.
So if you put a softener in your house, a lot of folks do, right? You see them go buy the salt and they put them in there and all. Do they work in getting all that out? Making the water softer, getting all the calcium out?
Okay, do they work in making it softer? Yes. Getting it all out? No.
No.
So what you're doing is you're relying on an equilibrium process there, and you're exchanging 2+ divalent cations, the calcium or the magnesium, with 1+, usually sodium. Do they use sodium chloride for this usually?
Probably.
But you're putting chemicals in there
switching
to switch out other
calcium
chemicals.
for sodium.
Yeah.
And sodium doesn't give you the hardness.
Right.
Make it easier on everybody.
Thank you.
I'm acting as his translator.
There you go. There you go. You're doing well. You're doing real well. So yeah, fluoride. I mean, here's the one. But what about the dihydrogen oxide?
Oh my gosh! No,
It's even in well water. Distilling doesn't get rid of it. So what is he talking about for the rest of us here?
hydrogen monoxide's a joke.
H2.
Yeah,
I got you.
it's water.
Too. Yeah. So what about the one? Yeah.
They were joking.
They were joking.
Yes. But it is interesting how deep you can go on the chemical.
Well, and it shows that people react in fear to hearing things like that, and then they find out, it's something that's all around, and that's kind of what's happening with a lot of this debate. Is people hear these chemical names, they hear synthetic,
Scary thing.
and they've just been
and that's where I was
they've
going to
been
go.
conditioned to be afraid of it.
That's where I was going to go with asking you about drinking carbonic acid. Doesn't
Okay.
sound like a great idea,
Right.
But let's say that theoretically, and he and I have both in analytical chemistry used as pure as you can get H2O, right? And that's not a simple process. But let's say that water somehow was absolutely only H2O in that bottle. As soon as you open that and it's exposed to the atmosphere, now it's a carbonic acid solution because it's going to dissolve carbon dioxide, which is going to complex with the H2O, make H2CO3, carbonic acid.
And another thing about pure water is if you only drank pure water,
Less you too.
you would die.
Yes.
It actually would take all the minerals out of your body slowly, and it would kill you over time. Maybe quickly.
A family.
So I mean, it's you've got to have those
A family
sodium
member,
and
I got you.
calcium and all that in there.
Family member who is a nurse made the comment. I was talking to a lot of family members over the holidays about about these issues, and she made the comment that however many decades she's been in nursing, she has never seen a fluoride poisoning case. However, she's seen 2 water poisoning
Wow.
cases where they were drinking too much water.
I did come up with another statistic I liked. So I looked up the chemical they use to treat for fluoride, and I did some math. So assuming
You did.
200-pound person,
Right.
and the toxicity of the compound, you would have to drink 14,000 gallons of water
Now,
to kill somebody.
Now, I'm going to add to that. I'm going to add that. Well, but these calculations are based on total mass intake, right? So I'm going to add that you've got to do that also without eliminating any of those.
Right, yeah. So I'm pretty sure the 14,000 gallons of water would kill you before the,
You're getting to a point where you've got too much water in your fluoride.
Yeah.
Going back to the simplest reason I asked for this episode, and I'm thankful that Elliot put this together for me with you two gentlemen, is talk about fluoride, because there's just not education out there. We've known about it. We know why it's there because we all heard, it's good for your teeth. But at the end of the day, a lot of folks think, well, hey, wait, though, I've heard fluorosis and other things. But I mean, right, at the levels we're at down here, it's for the benefit. It's not going to cause these problems, and the reasons we need it are important. And that's the information we need out there from folks like you two that went and got college educated and have done research and done things like that, because those are the opinions I value. Maybe not Joe on Facebook that, read a research paper from China, but he didn't really vet it real well, and it's a bad one, and here we go.
Well, and I think that going with that, another thing that we hopefully can encourage, and watching some of your past videos, I'm hoping that this is being encouraged here, is talking to each other instead of at.
Oh, definitely.
And I think this can be a step towards that.
Yeah.
I know that folks could call and talk to you. They definitely can with me. Yeah, I'm going to put you out there. James is a really nice guy and likes to talk to people, but he just doesn't like to tell you that.
Yeah.
Keeps the number low.
I just wanted to add one thing about the, the importance of, the idea of treatment and everything else, and really address the no chemicals aspect and the PFAS and everything else. So I give a water talk I've given a couple of times talking about water quality. And, one of the things the first thing I bring up is things like cholera and all the diseases that people are getting around the world. Like 90% of the world doesn't have real clean drinking water, like you'll die tomorrow kind of drinking water. And, we're kind of lucky. We're worried about microplastics and PFAS that might kill us in 20 or 30 years, right? Because majority of the world's worried about the things that are going to kill them tomorrow.
Yes.
And it's important not to take a step backwards and say, oh, we're not going to treat it with anything, because then you are going to have an increase in the diseases and things like not necessarily just cholera, E. coli is more likely, things like that. And, we're worried about the kids with the fluoride. I'm much more worried about disease and the cavities later on in life and stuff like that. So I just feel like knee-jerk reaction of don't treat, do everything completely all natural and holistic. And sometimes it's good, but sometimes it would be taking a step back, and I think the water treatment definitely would be taking a step back.
That's a good point.
Very good point. Yeah. When you're not living in those situations that folks around the world are living in, we don't understand, and we take it for granted.
Yeah.
We do. We take it for granted. We just open up the tap and grab some water and drink it and go on. I'm from Florida, so we always, down toward the coast, it was real sulfur. It had a sulfur smell to it or whatever. But hey, it didn't kill me, right? And like you said, there's countries around the world that, they don't know. There's no clean water sources because all the sewage and everything else just kind of flows all into one central water source. So
I've been there and seen that. It's not a pretty sight.
Well, hopefully we'll put the well upstream from our sewage, but but when it goes back into the water system somewhere.
Well, all of our sewage, if you're on sewer, goes to Chattanooga. So all of Catoosa County sewer goes to Chattanooga. It does. Okay. We don't have a treatment plant anymore. Now, years ago, we had one that was down off of Mack Smith Road, and the city of Fort Oglethorpe had that. But they decided it was more cost-effective for Fort O, Ringgold, the whole county. We all go to Chattanooga. So if we in now Walker County has decided they're going to reopen in the Chickamauga sewer treatment plant because how much groundwater is getting in and things of that nature,
Yeah.
the cost has gotten so high that they're going to go ahead and do it themselves. But, our topography here in Catoosa makes that more difficult to get it to flow that way where we could do that kind of thing here. But so we're lucky. We don't have to worry about a sewer treatment plant over here close by and things like that. So that, that is a blessing in that sense. So.
But a lot of your folks aren't sewer. There's probably a lot of septic
tanks.
tanks around.
Oh, yeah, sure. No, listen, there's not a lot of sewer, and that's good in a sense because, that's less development, things of that nature. But if you're out in the Keith community, if you're out in Cherokee Valley community, there's a lot of communities in our county that are rural that are on septic. Absolutely.
That will go directly into the groundwater.
Yep.
Directly.
Well, Yes, and
Needs to
hopefully
be.
well-designed septic system,
Yeah.
so there's some detoxification before it makes it to the aquifer, but that's where it's going eventually.
Yeah,
So,
yeah, it is. Good points. Any other thoughts, gentlemen?
well, let's keep up scientific communication. I think that's the big deal.
Yeah.
Yeah, no, and that's great. That's why I'm glad you two came today. I think this is an important topic to kind of start the year off with some good information for folks. I'm sure the folks down in Ringgold appreciate it because, it gives them one more source to say, hey, maybe you should just watch Sweet Home Catoosa and
you go.
watch these two gentlemen come on here and talk about the importance of fluoride in the water and kind of dispel some fears that have been out there that maybe aren't correct. And so I appreciate you two coming and doing that. So James, Eric, thank you too much for coming today. And hopefully you had a great New Year's and kept the consumption low on New Year's Eve. And until next time, thanks for watching and have a great week.